Welcome and greeting to the session of Introduction of Syllabus of HVACR, which stands for Heating, Ventilation, Air Conditioning and Refrigeration Engineering. It's an elective one of BA Mechanical course, Part 1, 2015 course. This is just the extension of the subject Refrigeration and Air Conditioning, what you have learned in TE Mechanical. Mainly, this particular subject includes the practical aspects of refrigeration and air conditioning. About the teaching and examination schemes, this subject has 3 lectures per week and 2 hours practicals per week. Examination, as usual, the theory of 100 marks and term work of 25 marks. 6 units covered, and the name of the units: advanced vapor compression cycle, thermal design of refrigeration system components, practical aspects of vapor compression system, ventilation and infiltration, heat transmission in building structures, and advanced air conditioning systems. So more or less, first 3 units belongs to refrigeration, and remaining 3 units belongs to air conditioning part. But all the units covered mainly the practical aspects and the commercial aspects of this particular subject. The references for this subject is not covered in one particular book. You need to rely on at least 3-4 books to collect the entire syllabus. But fortunately, I have collected all the materials together, and the same data will be available for you unit-wise on the Moodle. Most of the data is collected from the highlighted books like CP Arora, ASHRAE Handbook, HVAC Systems and Equipment, Refrigeration and Air Conditioning by Manohar Prasad, ASHRAE Handbook, Refrigeration 1998. So these are the books I have referred, and through these books I have collected the information and prepared the notes. Now we'll discuss each unit in depth, what about the contents of each unit. The first unit is advanced vapor compression cycle. In this particular unit, we have mainly discussed the 2 advanced vapor compression cycles, like transcritical cycles and ejector-based refrigeration cycle. But before that, we'll take a review of the fundamentals of vapor compression cycle. The exam point of view, it has no weightage, but first 1 or 2 sessions we will consume on the review of vapor compression cycle. Transcritical cycle, because vapor compression cycle, it is also called as a subcritical cycle, because both condensing and evaporating temperature happens below critical point. In transcritical cycle, one of the processes, especially the condensation process, it happens above critical point. So it is not called as a condensation process, it is called as a gas cooling. And this generally happens in case of CO2. So when we are using CO2 as a refrigerant in vapor compression cycle, it becomes a transcritical cycle. So CO2 as a refrigerant become a potential substitute for the current refrigerants like HFC 134 and R22. So in this particular concept, we will mainly discuss there are different configurations of transcritical cycle. Each modifications are made, and the modifications are especially made to enhance, to improve the COP of the system. So there are 5 to 6 modifications we are going to discuss in this particular topic or in this particular concept by considering its construction, working, and their important features. So only a theoretical treatment for transcritical cycle. Ejector refrigeration cycle, it is another advanced refrigeration cycle which mainly uses ejector as a device for compressing the refrigerant as well as suction of the refrigerants. Mainly we are discussing the 5 configurations of this ejector-based refrigeration system. So this particular system is available slightly in CP Arora book, but most of the contents we have taken from research papers, because this is coming up a potential substitute for vapor compression cycle, where the compressor is replaced by ejector, and the ejector, pump, and generator, like vapor absorption cycle. So here we will discuss the different configurations of ejector refrigeration cycle. mainly the basic refrigeration cycle, then ejector refrigeration cycle with additional jet pump, then multi-evaporator systems, integrated system with vapor compression cycle, and combined power and ejector refrigeration system. This particular concept also covers a simple numerical, that is numerical analysis of obtaining the cooling capacity, the power input, and COP of ejector refrigeration system. So this is what all about the unit number 1, where the numerical treatment is also there for simple ejector refrigeration cycle. Most of the uh, most of the content is the construction working of the cycles used in transcritical as well as ejector refrigeration cycle. So this is what the unit 1 is all about. Unit 2 is mainly based on the components of refrigeration system and their design aspects like compressor, evaporator, condenser, expansion device, and cooling tower. In compressor, we'll mainly focus on the reciprocating compressor. That's how to size this reciprocating compressor and the characteristics of reciprocating compressor as well as centrifugal compressor, because most of the almost 80 to 90% applications are covered by these two compressors till date. Nowadays, the centrifugal compressor is replaced by screw compressors, and reciprocating compressors are replaced by scroll compressors. But still, the characteristics available in the books are characteristic curves. That is a performance characteristic curves. We'll discuss in compressor part. Evaporator will mainly discuss the design aspects, so designing of DX type evaporator and flooded type evaporator. The two types of evaporators, only a numerical treatment we are going to cover. Condenser, mainly the design of air-cooled condenser and shell-and tube condenser. Again, the numerical part is there because the theory part you already covered in the TE syllabus, that is RSC. So here we mainly focus on only the numerical part. Expansion devices mainly focuses on thermostatic expansion valve, its construction working, its operating characteristics, and how charging of the uh, sensing bulb, and the different practical aspects of thermostatic expansion valve, because the setting of thermostatic expansion valve in practice is really a tedious work. So we'll mainly focus on that particular aspect of expansion device, besides the just focusing on different types of expansion devices. But exam point of view, these are the contents are important. Cooling tower. Cooling tower, we have one experiment on cooling tower, but cooling tower mainly will discuss the different types and design of cooling tower, that is how to analyze the performance of cooling tower. That aspect we are going to cover. So this is all about the unit number 2. Unit number 2 is more mainly a numerical oriented unit, where you can have a numerical on compressor, evaporator, condenser. So these are the 3 areas where you can have a numerical part, but also you can rely on theory as well. Then unit 3, it is a practical aspects of vapor compression systems. So here in this particular unit, we mainly discuss the different practical aspects of vapor compression system. Mainly the pipings used in vapor compression system. That is, copper piping is used. Some piping design, then size of copper tubing, then the sizing procedures, then what are the aspects of suction line, discharge line, and liquid line? These parts we are going to cover in refrigerant piping. Then comes the capacity controls, which are especially used in compressors to regulate the cooling capacity of the compressors. So in this particular uh, case, we mainly discuss with the capacity controls used in reciprocating compressors and centrifugal compressors. The safety controls used in refrigeration system we are also going to discuss here. That is safety controls in compressors, then safety controls in motors. That LPHP cutouts, then low pressure, low temperature controls, then fast controls, then oil pressure failure control in compressor, then motor overload controls. So mainly electrical part will be there. Vapor compression system balancing. So when the two components are working together, they should be work in uh, uh, harmony. So there is a question, there is a possibility of there is a question arises how this how these devices, especially compressor and condenser, compressor and capillary tube, how they work together and what are the balance conditions. So there we'll discuss if we superimpose the performance curves of compressor and condenser, it becomes a performance characteristic of condensing unit. And if we superimpose the performance curves of compressor and capillary tube, so it becomes a performance curves of compressor capillary combination. That is like refrigerator. So condensing unit, which mainly consists of compressor and condenser. This is about the unit number 3. Unit number 4, now onwards, the unit number 4, 5, 6, they belongs to a conditioning part. So unit number 4 is ventilation and infiltration. Ventilation is the supply of the fresh air to the room, that is called as ventilation, and infiltration, that is the air which is coming inside the room through opening and closing of the door, which is not a filtrated air. So that is abbreviated. That is these two terminologies are there. So here we mainly discuss with the indoor design conditions. There are 5 basic parameters which need to control in air conditioning, that is temperature, relative humidity, air velocity, and purity of the air. So what are the factors affecting the thermal comforts that we are going to discuss? Then the comfort discomfort diagram, that is HVACR comfort chart, that is modified HVACR comfort chart, we are going to discuss. Then we throw light on indoor air quality, that contaminants. There are 7 types of contaminants present in the air. So how to control this contaminants, how to improve the indoor air quality, that part we will discuss. Outdoor design conditions, what are the requirements of outdoor air, then what are the, how to utilize the weather data, then outdoor weather characteristics and their influences. This is about the unit number 4, that is ventilation and infiltration. In continuation, we will also learn ventilation for cooling. Ventilation is also used for cooling. So without providing the mechanical devices, we can still provide the cooling through the ventilation. So that technique we are going to discuss here with the help of wind and stack effect. Then space air distribution, where the design of air distribution systems. So air distribution is an integral part of a conditioning system, where what are the conditioning air, how that a conditioning air is distributed uniformly across the room, and what are the types of distribution devices used. So there are 4 to 5 devices are used, and their distribution pattern we are going to discuss. And there are simple numericals are also available. So as far as unit 4 is concerned, it's a theoretical unit, but still there are simple numerical of 4 to 6 marks on space air distribution and ventilation for cooling. So this is what the unit 4 is all about. Unit 5 is all about the heat load estimation in building structures. So here, in addition to the cooling load calculations, here we are mainly focusing on how to calculate the envelope load. Envelope load is the commercial term where the heat transmission to the building. So almost in most of the commercial buildings, 25 to 30% load is through the heat transmission through the structures. So there are 2 major techniques used in this particular to calculate the heat transmission load. That is decrement factor and time lag method, and CLTD, that is cooling load temperature difference. That is, so these are the 2 techniques used in heat load estimation in building structures. That is the main part of this particular unit. There are 12 marks numerical can be asked to calculate the heat load through building structures. So that part we are going to cover, and also we are going to discuss the energy conservation building code. So the concept of green building and what are the codes and policies used for this green building. That part we are going to discuss here. That is unit number 5. Then unit number 6, we are mainly we will mainly discuss the advanced air conditioning systems. Advanced air conditioning systems. There are 5 advanced air conditioning systems we are going to discuss. Like desiccant-based air conditioning systems, evaporative cooling air conditioning systems. We have already learned the desert cooler, that is of a direct evaporating cooling. So in this particular case, we'll discuss the combination of direct and indirect evaporative cooling air conditioning systems, one configuration. Then thermal storage air conditioning systems, clean room air conditioning systems, radiant heating and cooling. So these are the 5 advanced air conditioning systems which are used in combination or with the conventional air conditioning systems to improve the efficiency and to save the energy. So very important 5 air conditioning systems we are going to discuss with the help of schematic diagrams, their advantages, their applications, and important features. So these are the 6 units we are going to cover in HVAC and R. So mainly all 6 units, they are related with the practical aspects. So as a part of term work, there are 3 term work, 3 assignments for the term work. So first, that is a simulation, that we perform a simulation of central air conditioning plant using a numerical method, that is Newton-Raphson method. So with the help of numerical method, how we can analyze the air conditioning system or cooling load calculations, that we are going to see. Then performance analysis of counterflow cooling tower. If time permits, if the situation permits, we'll take this practical on our existing cooling tower. But if doesn't permit, then I have developed one simulator. So with the help of simulator, you can analyze the performance of counterflow cooling tower as well. Then building heat load simulation using suitable software that we can, okay, and the design of cold storage. So out of 4 experiments, we'll mainly focus, and all these 4 experiments have a practical weightage. These are the things which industry practices regularly. That is to calculate the cooling load calculation using numerical technique, then performance analysis of cooling tower and cold storage design. So all the commercial aspects we are going to cover in this term work part as well. So uh, I've covered the outline of the syllabus. So, but the question arises in your mind that why we should take this particular elective. So, whom should take this elective? That is the question. So, first thing, if you like to attempt numerical questions, so almost there are 60 to 70% numerical questions in SEM, especially numerical questions related with the HVAC and R. 50 to 60% numerical question will be there in same examination. But few students are like that. They like RAC, but they have a phobia about the numericals. So for those students, as per the question paper pattern, the earlier question paper pattern, there will be 100% theoretical questions available for you. Uh, that is the exam point of view. That is immediate. That is advantage of this. Some students think about the immediate benefit, that short-term benefit. But as a long-term benefit, if you want to pursue a career in HVAC&R, definitely this subject will be very useful. You want to pursue career as a businessman or career as a job, then you go for this particular subject. If you have a ASHRAE and ISHRAE membership, so it is mandatory for those ISHRAE and ASHRAE membership, because otherwise it is not justifiable to take the membership at ISHRAE and ASHRAE, because both societies work for HVAC field. So this will add your value in your resume. So along with the membership, you also gain the advanced knowledge of refrigeration and air conditioning. And if your project related with the HVACN field, because in TE also you have chosen some topics, and most probably you're going to carry forward that topic in future also. If your project is based on RAC, definitely you can think about this particular elective. But only if if you want to pursue, really if you have an interest in this particular subject, then go for it. Thank you very much. To join this particular course, I have developed a Genomia site where you can find the course material, the laboratory material, the quizzes, and the regular practices. So most of the content we are going to cover through this Genomia site. So some videos will be available, important videos. My self video is also available on this Moodle. So this is a site address, that is JSCOE mechphvac.genomio.com. So I hope this particular presentation will be helpful for you to choose the elective one. Thank you very much.